Let's dive in. Injection molding is the process that lets us make tons of identical plastic parts, fast. We melt plastic, inject it into a custom mold, and out comes everything from phone cases to car bumpers. It's the backbone of mass production for plastic goods, affordable, durable, and complex. Factories, designers, and engineers all use it to turn digital designs into real-world products. Even small workshops can use injection molding for specialized runs. Look around. Your remote, water bottle cap, keyboard, likely all made this way. Without injection molding, everyday items would be pricier or not exist at all. The process allows for intricate designs and consistent quality, making it essential for modern manufacturing. It's all about precision, speed, and reliability, turning plastic pellets into the stuff we use daily. Ready to see how it works? Meet the injection molding machine, a giant, powerful press with a precise heating and injection system. Key parts: the clamping unit holds the mold shut with tons of force, and the injection unit melts and injects plastic. The machine's food is tiny thermoplastic pellets poured into a hopper. Think of it as a cereal dispenser for plastic. These pellets come in different types and colors, each with unique properties. Gravity feeds the pellets from the hopper into the barrel of the injection unit. Inside the barrel, a reciprocating screw rotates, moving pellets forward and generating friction to preheat them. This screw is the workhorse, prepping the plastic for melting. The process is carefully controlled for efficiency and consistency. Every step ensures the final product is flawless. The screw's dual action, moving and preheating, sets the stage for perfect parts. It's a marvel of engineering, all about precision. Next up, how those pellets become molten plastic. Let's keep going. The pellets move forward. Thanks to the screw, and powerful heater bands melt them into a thick, honey-like liquid. The temperature must be just right. Too cool, it won't flow. Too hot, it degrades. The screw mixes and melts the plastic evenly, avoiding cold spots or lumps. As molten plastic builds up at the front of the barrel, the screw moves back, ready to inject. Once enough is ready, the screw acts as a plunger, set to fire the plastic into the mold. Sensors and computers control every detail: temperature, pressure, screw position. Each shot is precisely measured for consistency. This stage is all about getting the melt perfect. No room for error. If the melt isn't right, the part won't be either. Precision here means quality parts later. Now, let's fill that mold. Here's where the magic happens. The mold, two steel halves, clamps shut with massive force. The screw injects molten plastic at high pressure, filling every detail of the mold in seconds. Speed and pressure are critical. Too slow, you get incomplete parts. Too fast, you risk defects. After filling, the machine applies holding pressure to pack in more plastic, compensating for shrinkage as it cools. Cooling channels inside the mold circulate water to solidify the plastic quickly and evenly. The cooling phase is crucial. It takes up most of the cycle time. If you rush it, the part warps. If you wait too long, you lose efficiency. Think of it like making perfect ice cubes. Timing is everything. Once cool, the plastic is solid and ready to be released. The mold's design ensures the part holds its shape. This stage transforms gooey plastic into a finished product. Cooling is the unsung hero of injection molding. Next, popping out the part. Cooling's done. The mold opens, revealing the new part. Ejector pins push the part out cleanly, avoiding damage or marks. Sometimes, air or robotic arms help with tricky shapes. The part drops onto a conveyor or into a bin, ready for finishing or packing. As soon as it's clear, the mold closes and the cycle repeats, fast and efficient. This automation means thousands, even millions of identical parts with minimal human input. Cycle times can be just seconds for simple parts. Consistency and speed are the big wins here. Each part is a testament to engineering precision. The process repeats. Reliable, relentless, and impressive. That's how we get perfect plastic parts every time. Why all this effort? Because injection molding is unbeatable for mass production. Once set up, it churns out parts at lightning speed, parts per minute, even per second. It handles complex shapes and tight tolerances, making everything from tiny gears to medical devices. The surface finish is often excellent, straight from the mold. High upfront mold costs pay off with super low cost per part at scale. Minimal waste. Scrap can often be recycled. It's used for car parts, kitchen gadgets, electronics, toys like Lego, medical tools, and more. Injection molding shapes the plastic world around us. It's the cornerstone of modern manufacturing, fast, precise, and versatile. That's the magic of injection molding.